Hello, everyone. I'm Jillian Stugard, and I'm so excited to welcome you to our first lecture video. This will be all about learning some really important key vocabulary and getting a foundation for the basic principles that underlie statistics. So as you watch, make sure you have your guided notes and a pen or a pencil handy so you can jot down key definitions and examples, because we are going to be using these terms and talking about these concepts throughout the entirety of the course. So it's really important and essential that you have an understanding of what they mean and how to contextualize them. I'm excited. Let's get started. So we're kicking off our statistics journey by exploring some essential ideas, right? What is statistics and what are variables? How do we collect data in ways that are actually meaningful? All of these things are really important conceptual ideas and questions that we are going to need to know how to answer if we are going to be successful in this course. So let's talk about each of these questions in this video and break everything down for you. Let's start with that first key question. What is statistics? Statistics is a lot of things, but if we really boil it down to the two most important, it's both a science and an art. The definition of statistics: it's the science and art of collecting, organizing, summarizing, and analyze data in order to draw conclusions and answer questions. Yes, we will be using math, right? But statistics is more about how we make sense of the world through data. Think of it as detective work with numbers. Just like science, we'll start by building a strong vocabulary, and just like in art, we'll learn that data can sometimes be interpreted in more than one way and is a really creative and fun and interesting and relevant way to draw conclusions, think critically, and to make sure the information that we're reading about or hearing about or learning about is actually accurate and relevant, and we can believe the conclusions that are drawn, or how certain are we about those conclusions that are drawn. So it is one of the most applicable courses, I think, to your everyday life, because it really helps you become a better critical thinker and problem solver. All right, so let's move into our sort of second question here. Why does data collection matter, right? Why is it important to collect data? So let's think about this in terms of a scenario. Let's say you hear a claim like 70% of Americans think taxes are too high, right? So think to yourself, did they ask you that question? Where's that 70% coming from, right? Did they ask you that? Probably not. Did they ask every American that question? Do you think taxes are too high? Probably not. So how do they know that, right? Where did that 70% come from? They didn't ask everyone, but they actually didn't need to. And that's really the magic of statistics. We're learning about a whole group using just part of that group. Now, there are three parts of statistics, right? So the first is what we're going to be studying in kind of like the first third of this course. It's called descriptive statistics. And that's how we describe data using graphs and numerical summaries like mean or median, things like standard deviation, all of that. The second type we'll talk about in sort of the second third of this course, probability. And probability helps us understand uncertainty when we work just part of the data. What are the chances of X happening, or what are the chances of X happening given Y? Things like that. The last is kind of the last part of the course, in the final third of the course, inferential statistics. And that's where we're going to draw conclusions or make predictions based on those first two types of statistics, the descriptive statistics and the probability, the things that we've already collected. Keep in mind, statistics rarely gives us sort of the single one right answer, right? Instead, it gives us confidence. It's sort of like, well, this is the best we can do with the data. This is how confident we are in the data given this margin of error. It's never like, it's not like typical math and where you're like, this is the one right answer. And that's sort of the beauty of it. We can draw conclusions based on the data we're given at that moment in time, and then we can say how confident we are about those conclusions. But things are always changing in the world, right? And so statistics gives us a way to kind of describe that change too. Let's begin with a few key vocabulary terms that you will hear for the entire duration of this course, so it's really important you get to know them well. The first is population, and when we talk about a population, we're talking about the entire group we want information about. The next is sample, and that's when we take a smaller group from that population that we actually observe or study in some way or survey. An individual drills down even smaller. We take an individual single member of that sample. So an individual is sort of like one person or one thing from the sample that we're drawing. So for example, if we want to know how all Americans feel about taxes, in this context, our population would be all Americans, that big old group, and then we're going to drill down to the sample level where we might take 1,000 of those Americans that we survey, that's our sample, and then drilling down even further, an individual from that sample would just be one person that is surveyed on this question. So here's a few more really important key terms that you will need to know in vocab for the entire duration of this course. A census is when we collect data from every member of the population. It tends to be pretty rare and expensive. The government only does this every few years because it's so expensive. My husband for one of the censuses a while back was actually a worker who would go around to people in town and in the neighborhood and ask questions and sort of take this data. Other times you might get phone calls or you might be mailed something in the mail, and it's like this huge data collection of the entire nation, as many people as possible. Like I said, those are very rare and expensive. A parameter is a number that describes the population. And remember that population is that bigger group that we're pulling a sample from. A statistic is a number that describes the sample. So from that population, we're pulling a sample, and our statistic is going to describe something about that sample. Okay, now here's a quick trick to kind of help you differentiate between these two words, statistics and parameter and statistic. Parameter begins with a P and population begins with a P. So just remember that parameter is a number that describes the population, whereas statistic begins with an S, as does sample, and a statistic is a number that describes the sample. So parameter, population, statistic, sample, okay? Putting this all together in context, we use sample statistics to estimate unknown population parameters, okay? And we'll always include some sort of margin of error to show how certain uncertain we are about what we're saying, the conclusion we're drawing about that statistic or that parameter. All right, now let's discuss variables in statistics. There are two main types. A variable is any characteristic that can take on different values, and hopefully this isn't the first time you're hearing the word variable. In statistics, the two main types that we talk about are quantitative, also known as numerical variables. Think about things that you can measure meaningfully, like height, age, or number of pets. As a rule of thumb, and this is really important, if you can subtract two values and it makes sense, it's probably quantitative, okay? So it's probably a quantitative variable. So for example, someone's year of birth, right? If I subtract this year, the year that someone was born from this year, I can figure out their age. That's meaningful, making year of birth a quantitative variable. The second type of variable is called a qualitative variable, okay? These are also called categorical variables. And these tend to be descriptive labels or traits like eye color, favorite season, yes, no answers, right? So when you think quantitative, think quantity, number, whereas qualitative, we think some quality or category that's describing something, okay? So something that's really important, a heads up, if you will, qualitative variables can sometimes be masked in disguise, and they try and trick you because even numbers can be qualitative or categorical variables. So this rule of thumb appears really important, and this tends to be something that beginning statistics students struggle with, determining whether something is a quantitative or qualitative variable, because sometimes numbers can be qualitative or categorical variables. So let's look at an example of that. A phone number, right? phone number, you see phone number, you see numbers, you think, oh, I see a number, it has to be a quantitative numerical variable. Actually not, because if we run it through that rule of thumb, if we subtract two phone numbers from each other, do I get something meaningful out of it? Well, no, that doesn't actually tell me anything. So actually, phone numbers happens to be a qualitative or categorical variable. And so it's always good to just stop and think and run it through this rule of thumb. Try subtracting two of them. If you get something meaningful, it's probably quantitative. If you get something that doesn't mean anything, it's probably qualitative. So be really careful. The sort of like headline here is be careful, the context matters, right? A $100 prize might be considered categorical in a contest because we're actually, we're not necessarily talking about the number $100. We're talking about, are you winning it or are you losing it? Those are our two categories. Yes, no questions also tend to throw students off. So just be really careful and make sure you're running it through that rule of thumb and you should be good to go. Okay, so now that we sort of have a foundation of understanding for variables, let's talk about the response variable versus the explanatory variable in statistics. So in research, the response variable is the outcome we're studying. So it's sometimes called the target variable. The explanatory variable helps explain or predict the response. So we're sort of thinking about, okay, if we do X, what happens to Y, right? And we'll put this in context in a minute. And so the response variable, think of it as, well, what happened, right? Well, what's the outcome here versus the explanatory variable? Well, what did we do to get that outcome? So for example, if we want to see if, here's my first variable, hours of sleep affect, here's my second variable, test scores, right? The response variable is the test score, and the explanatory variable is the hours of sleep. And so the response variable, right, is the outcome we're studying. Well, what test score do we get based on the explanatory variable, right? The number of hours of sleep that we're getting. Okay, so in statistics, we'll often want to explore how one variable affects another. And the contexts that we study in this class are going to have these two variables, a response variable and explanatory variable. And sometimes you really have to sit down and say, well, which is the one that's giving me the outcome versus which is the one that's predicting that response? Okay, but there is something you need to beware of, and that is called confounding, which is can be caused by lurking variables. So confounding is just a fancy way of saying that multiple variables may influence the response in a way that's sort of hard to separate from the variables we're actually studying. And a lurking variable is one of those unconsidered variables that secretly influences the outcome. So it's almost like this thing that we didn't even realize was affecting our response variable, and like it's not something that we set out as one of our variables, like this is going to be a variable that we study, but it winds up actually influencing how our experiment plays out. So let's look at an example here. People who use sunscreen more, so people who use more sunscreen are actually more likely to get skin cancer. And you look at that and you think about that for a minute and you say, what? That doesn't make any sense, right? Does sunscreen cause cancer? Well, no, right? Or is there a lurking variable here, right? So think about it. People who use sunscreen more are more likely to be spending a lot more time outside, right? And if you spend more time outside, you may be more likely to get skin cancer. So that time spent outside actually is a lurking variable that winds up influencing this experiment. And this is why understanding study design is just so important. Okay, and you always want to make sure that you design your study in a way that thinks about and tries to identify any sources of lurking variables or confounding. Okay, so now let's talk about the two main ways that we collect data in statistics, and they are through observational studies and design experiments. And these are both very different creatures. Let's start with observational studies. So in an observational study, we simply watch and record. We do not impose something called a treatment. It's literally researchers just sort of basically sitting back and observing what happens. It's exactly what it sounds like, right? We're just simply observing. So an example of an observational study would be a public health researcher tracks the eating habits and heart health of 1,000 adults over 10 years without changing their diets. So they're not really imposing anything. They're just sort of sitting back and watching what happens when these 1,000 adults just sort of eat the diet that they're eating over the course of 10 years, right? They're observing and recording natural behavior. They're not imposing any sort of a treatment here. Now, the thing about observational studies is that we cannot claim causation. The best we can do is claim correlation. And that's because in an observational study, researchers do not control or assign any variables. They just watch what naturally happens, which means other factors like confounding lurking variables might be influencing the results. We just don't know, right? We just are kind of sitting back and watching. You can't be sure that one variable actually caused the other, but we can claim that maybe they're correlated in some way. They can still show patterns or relationships between variables. So we can say that two things are linked or associated, but not that one caused the other. However, in a designed experiment, we can actually, it's a little bit different. So a design experiment is when researchers impose a treatment, okay? So the researchers actually kind of have control over some variable here. So for example, a medical team randomly assigns 200 patients to take either a new cholesterol drug or a placebo, and then compares cholesterol levels after 6 months. So here in the experiment, the researcher is actually dividing this group of individuals into this sample into those that take an actual medicine and those that take a placebo, and maybe they don't know which one they're in. So everybody's taking something, but one group is taking a placebo, which means it doesn't actually do anything to you. It's not actually any sort of medical intervention. It's just a pill that has absolutely no effect on your body. So here, the researchers are imposing a treatment and have a controlled group so they can actually test for causation. So designed experiments are more controlled. They require a treatment, something that researchers are imposing on the individuals in this experiment, a control group, sometimes a placebo, and sometimes oversight by an institutional review board and informed consents from patients, right? You need patients' permission to give them medicine or whatever you're imposing on them, whatever the treatment is. And they need to be there needs to be confidentiality imposed in a design experiment. You need to keep things confidential. So here we can actually test for causation because we have that treatment being imposed, and we can see if it's actually making a difference in the testing groups, which is really interesting. So now let's apply what we've learned through 4 different examples. So for each example, I want you to think these 3 questions, jot down on either your guided notes or a piece of paper, and then I'll kind of go through and give the answers. So the 3 questions are, is the scenario an observational study or a designed experiment? What is the response variable, and is it qualitative or categorical or quantitative numerical? And then what is the explanatory variable? And again, is the explanatory variable qualitative or is it quantitative? Please pause the video when prompted and try to think through these questions and note your responses. The best, most powerful learning will happen in that 30 to 60 seconds that you take to think through these questions yourself. I can't stress that enough. If you are an active learner in this course, you will get so much more out of it than if you are just simply passive and watching and not actually doing the work. So it's not, these aren't hard questions. No, if you get it wrong, who cares? I'm never going to know. And actually, research shows if you get something wrong, you will learn it better than if you get it right off the bat. So take the time. It's not going to take you long. Let's start with the first example. Okay, here's example 1. A researcher records the color of cars that run red lights. So again, think through those three questions. Is it an observational study or experiment? What's the response variable, and is it quantitative or qualitative? And what's the explanatory variable, and is it quantitative or qualitative? So please pause the video and then come back and I will give you those answers and we'll talk through them. Okay, so hopefully you actually paused the video. So let's go through those three questions for this example. Is it an observational study or experiment? This is definitely an observational study. The researcher is simply watching and recording those cars. No treatment is imposed. The response variable is whether the car runs a red light or not, right? That's sort of like the end result. Is this quantitative or qualitative? This is qualitative, which makes it a categorical variable because we're just, yes, it runs the red light, no, it doesn't. The explanatory variable is car color here, right? Does car color, are red cars more apt to run red lights? Are blue colors more apt to stop for a red light, right? That's kind of what we're trying to figure out to explain what makes these cars run a red light. So this is qualitative, right? This has nothing to even do with numbers. This is kind of an easy pick. We're just talking about colors here, a category like red, blue, and black, okay? So why might somebody run this experiment, right? The researcher might want to see if a red car is more likely to run red lights, right? But they're not actually assigning car colors or controlling drivers. They're just observing. So this is an observational study. Okay, let's look at our second example. In this example, a botanist tests whether coffee grounds affect plant growth. If you add coffee grounds to plants, do they grow better, or does it have no effect, or does it make them grow worse? I don't know. So pause the video, see if you can figure out, is this an observational study or designed experiment? What is the response variable, and is it qualitative or quantitative, and what's the explanatory variable, and is it qualitative or quantitative? So pause the video and we'll come back in a minute. Okay, so hopefully you actually pause the video. So in this example, it is a designed experiment, right? The botanist is imposing a treatment here. Some plants are going to get the coffee grounds, some plants are not going to get the coffee grounds. The response variable, what are we actually trying to measure? What's the outcome here? That's how does the plant grow or not grow? What's the plant growth here? Now think about it. This is a quantitative numerical variable because we're measuring that plant growth in inches tall, or maybe number of leaves, or some sort of quantity. The explanatory variable, on the other hand, right, what might explain the plant growth, right, is whether coffee grounds were used. This has nothing to do with numbers. This is qualitative. It's categorical. Either yes, it got coffee grounds, or no, it didn't. Let's look at our next example. So here in our third example, we're kind of throwing it back to that study that finds people who use more sunscreen have higher skin cancer rates. So again, I want you to think, is this a designed experiment or an observational study? What's the response variable? What's the explanatory variable? Are they qualitative or quantitative? Please pause the video and see what you come up with. Okay, I hope you actually paused it and tried it. You will learn better, I promise. So is this an observational study or experiment? This is an observational study. And honestly, if you stop to think about it, guys, this has to be an observational study. You cannot ethically, and ethics plays into statistics a lot, potentially give people skin cancer. You just can't design an experiment where you might give somebody cancer. You might harm them in some way. So the best you can do is just sort of observe. There was no treatment imposed here. People just naturally use the sunscreen on their own. We're not saying, hey, you use it, you don't, and you might potentially get cancer out of it, right? We can't do that. Ethically, that's wrong. The response variable, what's being measured? Here we're measuring skin cancer rates. Now this is interesting because this really, the type of variable here depends on what question we might ask. It could be qualitative and categorical, because we might be asking, did you get it or did you not get cancer? That's a yes, no question. That would be a qualitative variable. Or we might decide we want to measure the rate of cancer, or the percentage, the likelihood of getting it. And that would be a number. So here it would be, in that context, it would be a quantitative variable. So you really have to kind of think through, what's the question we're asking? What's the context here? The explanatory variable, what might explain why somebody would be getting skin cancer? That's the amount of sunscreen used. And again, context matters here, because this could be a quantitative numerical variable if we're just saying, well, they use 2 ounces of sunscreen or an ounce of sunscreen or whatever. But it could also be qualitative or categorical because we might just kind of group it into categories of high sunscreen use, medium sunscreen use, low sunscreen use. So context really matters. And it depends on, what we ask and how we collect that data. And this is our fourth and final example. So here we have experiment tests whether vitamin B affects heart disease outcomes. So ask yourself those 3 questions, jot down your notes, and I'll be back in a second. Okay, I hope you actually did it. So is this an observational study or design experiment? Well, it's right. It was right in the context, right? This was a designed experiment. Participants are randomly assigned to either receive vitamin B or a placebo. So we do have a treatment imposed here. The response variable, what's actually being measured? Well, we're trying to figure out what's the heart disease outcome here, right? It could be, again, we have to think through how are we asking this question? What's the context? It could be qualitative or categorical if we're kind of grouping it into categories of did this individual have a heart attack or did this individual have no heart attack? Or it could be quantitative or numerical if we're measuring something like their cholesterol level or the artery blockage percentage, something like that. The explanatory variable, what might explain this outcome for heart disease, is that treatment that we impose, right? That vitamin B treatment. So this is qualitative. They either got the placebo or they didn't, right? Or they got the vitamin. Okay, we have 2 categories here, vitamin versus placebo. So that would be qualitative or categorical. Okay, a few final takeaways here. And this is kind of the slide where you want to be like going through each of these things and saying, can I do that? Check. Or if I can't do that, I need to kind of go back and review either my text or this video or whatever. So you should now be able to define population, sample, individual, parameter, and statistic. Identify and classify variables as qualitative or categorical or quantitative or numerical. Explain the difference between a response variable and an explanatory variable. Describe what makes a study an observational study versus a designed experiment. And recognize the limitations of observational studies in establishing causation. That's an important one that you'll need to apply again. This is your foundation for everything we'll be doing in this course. You'll apply these ideas again and again and again. So take time to review, take notes, ask questions if you need help, go back, rewatch, go back, reread, email me, reach out, whatever you need to do. Great job getting through this first video. Onward to the next step in your SATS journey.